but I'm going to show you a way to make this a little bit easier. So you can use the periodic table to get the order is even shorter yet. It's called noble gas notation. The first question that my students ask is, do I have to memorize that order of the increasing energy orbitals? And the answer really is kind of yes, but I'm going to show you a way to make this a little bit easier. So go to your periodic table, and what I want you to do is label the periods. And so the periods are the rows, the horizontal rows. So we have 1, 2, 3, 4, 5, 6, and 7. Now these, the little bottom section, you know, that little group goes up here, and this group goes up in here. So the periodic table has just been cut and drop those rows out. But anyway, they belong up in there. So the next thing I want to do is show you the blocks. Okay, so this little section right here is 2 elements wide. This is what we call the S block. And then this section here is 10 wide. This is what we call the D block. And then this section is 6 wide. We call that the P block. And then this section is 14 wide, and we call that the F block. Do those sound familiar? Those are the names of your sublevels, the different types of orbitals. Okay, now here we go. We're going to start, by the way, this is an S. He belongs really over there. Okay, so just picture helium over there on the left-hand side. So we're going to go left to right, and we're going to create that order. So I'm going to start off with level 1, and that is the S block. So I have 1S. That's it for the first row. Go to the second row. What do you come to first? Well, this is an S orbital. It's on level 2, so there's 2S. And then we go across here and we hit some P orbitals, and that's on level 2, so that's the 2P. All right, we're done with that row. Let's go to the next level. So we're going to hit the 3S, and then we're going to go across and hit the 3Ps, and then we're done with that row. Let's go to the next row. We're going to hit the 4S, and then we run into the Ds. Now that's not the 4D, that's the 3D, okay, because we first have a D orbitals on level 3. And you're like, wait a minute, why did that 4S sneak in there between the 3P and the 3D? That's not fair. Well, they go in energy order, and that's just what we observe. So the next one would be the 4Ps. Are you tracking with me here? Go to the next row. We're going to have the 5S, and so on. The next one would be, those are the 4Ds. So you can use the periodic table to get the order. This is my first little shortcut right here. Use the periodic table to get the order. Now, if you're doing electron configuration, you're probably not going to have to do one any bigger than needing the 4p orbitals, because that would be a whole lot of electrons. Now, let's keep going, and we're going to look at 3 ways to show electron configuration. The first one you already know how to do, and that would be orbital diagram. So let's do potassium. I've got 19 electrons. Where do we always start? With the 1s. I'm going to make a couple orbitals here because I know how this thing begins. All right, I know I'm going to need the 3s, and then I think I'm going to need the 3p's. All right, let's go. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. One more electron. I've got to go to the 4s orbital, and I'll put my last electron there. Okay, that is it. That's the longest notation, orbital diagram. Okay, now I'm going to show you something real quick. Let's jump on back to our periodic table. Guess where potassium is located? He is located right here. Okay, look where his electron configuration ended up. 4s1. Interesting, huh? Okay, the next thing we're going to do is what we call electron configuration. And we're going to take this orbital diagram, and we're going to make a shorthand notation. So in the 1s orbital, how many electrons did we have? 2. We're going to use that number of electrons as kind of like a superscript. And then the next orbital was the 2s, and we had 2 electrons there. In the 2p orbitals, how many did we have? Look at those. 2, 4, 6 of them. Okay, and then in the 3s orbital, we had 2 electrons. And the 3p orbitals, we had, it was all full. We had 6. And then in the 4s, we only had 1. How do you like that? So that is a little bit shorter. That is called electron configuration. This one is very, very common. In fact, that's probably the most common way that we show the electrons in an atom. The last one you're going to love is even shorter yet. It's called noble gas notation. So what you do is on your periodic table, you're going to find your element. And so this is potassium. You're going to find potassium, and then you're going to go backwards until you hit the last, which is in that last column over there. And so potassium is right after argon. Argon is the last noble gas. And we're going to use argon, since it's our last noble gas, and we're going to put it in brackets. And what that means is the brackets mean, hey, whatever the electron configuration is for argon, we're going to put that there. Okay? In other words, we're kind of too lazy to write it all out. Well, guess how many electrons argon has? It has 18. All of that is summarized in that bracket with the argon symbol. Okay? So what we're saying is, hey, potassium is just 1 electron bigger than argon. So whatever argon was, just add 1 more electron and it goes in the 4s orbital. So that is the shortest of all, noble gas notation. And that's really handy if you're doing like a really, really big atom. So we go backwards to the last noble gas and then add what's left over. All right, a couple more practices. Electron configuration for calcium. Calcium has how many electrons? It has 20 electrons. So here we go. 20 electrons. So I've got 2, 4, 10, 12, 18, 20. Now let me show you how I did that so fast. Look where it ended up, 4s2. I'm going to go back to my periodic table. Guess where calcium was? This is calcium right here. Level 4, and it was the second in the s orbitals. That's my shortcut. All right, name the element. So if you get an electron configuration, how do you name that element? Well, actually what you can do is add up all those numbers. Okay, if you add 2, 2, 6, 2, and 2, you're going to get 14. And 14 electrons is silicon. Okay, the next one, well, go to argon, and then we're going to add how many electrons? 5 more. So find argon, and argon is a noble gas right here. It's number 18, and they go 5 bigger, and that gets you to 23, which is vanadium.